More thermochemistry problem here. So we got Q is equal to mass of the object, specific heat, delta T, MC delta T, also known as MCAT. Here we go. So it's asking for what is the final temperature. So that's the delta T component. Remember, delta T is equal to T final minus T initial. Okay, everything's in Celsius. Yes, let me check. And this is mass, and we got this is Q, but it's let me see. The final temperature is water is heated, so it's gonna be positive value. Okay, so we got 31380 joules is equal to mass of water. It's 2500. That's 2 sig fig grams. And then times by specific heat of water is 4.184 joules over grams over Celsius. And then delta T, instead of delta T, I'm going to put T final minus initial would be 80.57, and that's Celsius. So if we find T final, it's going to be in Celsius. Okay, if we divide, I'm going to divide these two terms, okay, over here. So it's 2500 grams divided by 4.184 joules over grams, then Celsius. Oh, before that, let me cancel Celsius out, but T final is going to be a numeric value. That's going to be in Celsius. So grams will cancel and joules cancels, and C already canceled over there. Okay, so grams cancel here, and joules is equal to joules. They cancel out. Okay, so I'm going to divide. We get exactly 3. Now, this is a tricky part because that 3 is actually 3.0. Because when we divided, the least significant figure is 2 because of this guy. Now that's equal to T final minus 80.57. Now after division, we're going to be add and subtract. So significant figure rules differ here. So T final is going to be 3.0 plus 80.57. Okay, let me shrink this a little bit. When you add or subtract, you know that you have to use the least precise one. You could think about it this way. So 3.0, I'm going to add 80.57. And just add right now. So it's 83.57. When you look at the first term, 3.0, the precision is all the way up to tenths or first decimal place. When you look at the second one, the precision is all the way up to hundredths, which is the second decimal place. So when you add or subtract, you want to keep your answer to the least precise one. Least precise is tenths. So you could even draw a line here. So you want to have all the way up to here, this place. And then you still have to look at the next one, see if it's rounded up or rounded down. 7 is greater than or equal to 5, so you're going to round it up. So T final is going to be not 83.57, you have to round it up to 83.6, and unit is degrees Celsius. So that should be the answer for the first one. Let's do the next one. Okay, the second one says a sample of silver now. So I have found a specific heat for silver. It's that. Mass of 12 kilogram. Okay, I don't like that because you see how when you look at the specific heat, the mass is in grams. So let's change M into 1, 2, add 3 zeros to it. Now that has a 2 sig fig. Notice that. Oh, releases that amount of energy. So Q will be, since it's releasing, Q is going to be negative 60,000. Okay, joules. But this is 1 sig fig. Keep that in mind. This is 1 sig fig. Okay, sig fig. What is the initial temperature? So remember, delta T is going to be T final, which they give you. It's going to be 13.0 minus T initial. Okay, we're looking for that T initial right there. Let's set it up. So negative 60,000 joules. You know what? This time I'm not going to write down all the units here because all the units are there. 60,000 should equal to M 12000 C 0.233 delta T. I'm going to put 13.0 minus T initial. So I'm going to divide it out. So divided by 12000. divided by 0.233. So these two cancels out. Let's see. Is equal to 21.45. It keeps going. 459,227, blah, blah, blah. That's equal to 13 point, it should be negative. 13.0 minus t initial. Okay. But since we divided, and then we're gonna add and subtract now. So let's figure out the sig fig. Because of this negative 60,000, that's one sig fig. So I'm gonna underline here, signifying that that's my sig fig here. So I'm going to solve for Ti now. So if I bring it to the left side, T initial is going to be 13.0 plus 21.459227, and on and on and on, dot, dot, dot. Remember, this sig fig is all the way up to here. So when you add, the precision here is in one decimal place, but here is in tens. Tens, right? This is one decimal place. I'm just going to put one decimal place. Okay, let me make it a little bit smaller here. So T initial is going to be, now when you add, you have to have answer. Let me just add for now. So it's going to be 34.459 and on and on and on. But we have to, since we added, we have to have our answer in the least precise, which is in tens. So I'm going to have Ti is equal to 30 degrees Celsius. That's how you do this.